Okay, class, welcome back. In the last video I showed you how the change of base formula works. In this one I'm going to show you why the change of base formula works, alright? I'm going to construct a little proof for you. Okay, so the first thing to realize is that logarithms and exponents are essentially the same thing written in two different ways. So I want to look at two different ways of representing the exact same thing. So we will just go ahead and start with log base a of n equal to x, alright? And what does that look like when it's written as an exponential equation? Okay, well, our base is going to be a, right? Our exponent, the thing that's isolated over there, is going to be here, and that's equal to our argument n, alright? So let's get going with our proof. So the first thing I want to do is looking at this side, this exponential equation. I'm going to use my property of equality for logarithms. Some people call it the bye-bye log. Yeah. So if you have the same log, the same base log on both sides, they can cancel out. But that also means that I can add the base, or rather apply the same base logarithm to both sides, and the equation will remain balanced. Okay, so that's what I'm going to do. I'm going to this side of my equation, I'm going to apply log base b to it. So log base b, a to the x, and if I do it to the left side, in order to stay balanced, I need to do it to the right side as well. So log base b of n. You know, I didn't give myself much room, so I'm going to go ahead and move this over. Alright? Alright. Okay, so that is the first step. The second step is to realize that I can use my power property of logarithms. This exponent here, I can pull it out in front, and that is exactly what I'm going to do. Okay, so that this left side of the equation is going to get changed to log x times log base b of a, and I have not changed the right side. Right? I'm just leaving it the way it is. Okay. Okay, so I'm gonna, at this point, what I really want to do is I want to get x by itself, and how I'm going to do that? Okay, x is being multiplied by log base b of a. And so in order to get this x by itself, all I have to do is divide both sides by all of this. So that's what I'm going to do. Alright? So this side, let me just get rid of that little line. Okay, so this side is going to be divided by log base b of a. And this side is going to be divided by log base b of a. Okay? On this side, anything divided by itself is just 1, so I can just cancel that out. 1 times x is x. So what do I have? I've got x equals log base b of n over log base b of a. Okay, this right here should look very familiar to you. But check it out. This is where the final step of the proof comes from. This is equal to x. And this is also equal to x. That means that this must, by, I think the transitive property is what I'm thinking of, they must be equal to each other because both of them are equal to x. So finally, what we have is log base a n is equal to x, but what is x equal to? X is equal to log base b of n over log base b of a, and that's it. There it is. Right here is the formula that we started with, and I hope that you could follow this proof. It's very elegant, it's very short, it's not very complicated, but it does show why this base formula is true. Okay, so now you can be confident that you're not just plugging in some nonsense that, you know, the math teachers just say, hey, you know, just plug this in and don't ask questions. Now you know it works, as long as you follow it along. Anyway, I hope you're satisfied. Bye.